In this video, we're going to divide radicals, and the steps for division is identical to the steps for multiplication. You can divide a radical by a radical. You're going to divide any coefficients out front, then you're going to use the quotient rule that says the nth root of a over the nth root of b can be combined into the nth root of a over b. The same way you can split it, you can combine it as well and just divide the numbers. Then you're going to just simplify the resulting radical. So let's work some problems. Let's start out with the 12 and 2. 12 divided by 2 gives you a 6. Then you can divide a square root by a square root. The square root of 160 divided by the square root of 5 is square root of 32. That's it. Divide the coefficients, divide the radicals, and then let's simplify. The square root of 32 is root 16 times root 2. 6 times root 16, that's 6 times 4, which is 24 root 2. Next one, number 2. Divide your coefficients. 36 divided by 9 gives you a 4. And then you are left with a fourth root of 1250 divided by 2 is 625. And we actually know the fourth root of 625, that is equal to 5. So this would be 4 times 5, which is 20. Number 3. You can divide these. They're both under radicals, or they're all in radicals. So you've got let's go ahead and leave our radical. The square root of x to the third over the square root of x squared. Subtract those, that leaves you with a single x. Y to the ninth over y to the fifth, subtract those, that leaves you with 4 y's. So there's what you now have, and we can simplify that. Now, the square root of x you can't do much with, but I know the square root of y to the fourth, so you can split that if you'd like to. And the square root of y to the fourth is y to the second. So let's write that first, and we're going to leave the square root of x as is. Next one, 28 divided by 4. Treat that just like you would a fraction. That's 7. And you're left with a third root of negative 16 divided by 2 is a negative 8 is left under there. You have 6 m's and 1 m. That subtracting leaves you with 5 m's. Now let's split that. Leave the 7. The cube root of negative 8 I know. And m to the fifth, you can only do cube roots of multiples of 3. So the largest multiple of 3 less than 5 would be m to the third. So I'm going to split m to the fifth into m to the third and m squared. So I now know that 7 times the cube root of negative 8 is negative 2. 7 times negative 2 would be a negative 14. The cube root of m to the third, well, I don't know that one. I know this one. Cube root of m to the third would be m. And left underneath the cube root symbol would be m squared. Number 5. Square root of 48 over 16. You can split this into root 48 over the square root of 16 is 4. Then you can simplify the top. That's root 16 times root 3, which is 4 root 3, well, leave the 4. So you have 4 root 3 over 4, and the 4's would cancel. Leaves you with root 3. Or, from the get-go, 48 divided by 16 is 3. So you could have just done that as well. That would have been much easier. Okay, number 6. The cube root of 40 over the cube root of 27. Again, you can always split radicals. And I know the cube root of 27 on bottom, that's pretty easy. That's just 3. But on top, is there a perfect cube root inside of that 40? The things that you know the cube root of is 8, 27, 64, and so 8. I can split into 8 times 5. So on top, you're going to have a 2 and a cube root of 5. On bottom, you have a 3, and that's simplified. Number 7. Always clean up the inside first if you would like to. 7 and 64, there's nothing you can do there. Well, the x's and y's, nothing you can do there either. So let's go ahead and split it. You have the cube root of 7x to the fifth on top. You have the cube root of 64y to the sixth on bottom. The cube root of 7, there's nothing you can do with that. However, you can split the x to the fifth into, again, a multiple of 3 is what you're looking for. So that'd be an x to the third and an x to the second. On bottom, the cube root of 64 you know, and the cube root of y to the sixth you know. So we can go ahead and clean these up. Cube root of 64 is a 4. Cube root of y to the sixth is a y to the second. So now go back to the top, and the cube root of x to the third is an x. and the other 2 you don't know, so we're going to leave the other 2 underneath this radical, so 7x squared, and on bottom you have a 4y squared, and that's it. Next one, nothing cleans up inside of the radical, so let's go ahead and split it into the 4th root of 32w on top and the 4th root of 81 on bottom. 4th root of 81 on bottom, pretty simple. That'd be a 3, because 3 to the 4th power is 81. Now the 4th root of 32 on top, let's split that into, I know the 4th root of 16, so we'll split it into the 4th root of 16 times 2, and the w, I don't know it, so let's leave it. So on top, I now have the 4th root of 16, which is a 2. The other 2 4th roots I don't know, so put them back under a single radical and then leave the 3 on bottom, and that's all. Rationalizing. Now, rationalizing is the process of getting a radical off, in this case, the denominator. You can, later on, we'll rationalize numerators, but to rationalize the denominator, we need to get rid of this radical. Here's how you do it. If it's a monomial denominator, which means just one term, you simply multiply the numerator and denominator both by that radical. If it's a binomial, you're going to multiply the numerator and denominator by the conjugate. The same expression, but opposite signs in the middle. So let's go through the process. How do I get this radical off bottom? Which is a rule in math. We don't like, for some reason, radicals on the bottom of fractions. So we're going to multiply top and bottom by that radical. On top, it doesn't multiply, so you leave it as 3 root 5. On bottom, you have 2 times root 5 times root 5. When you multiply a radical times itself, it simply removes the radical. So on bottom, you have 2 times 5, which is just 10. So this is 3 root 5 over 10. No more radical on bottom. Number 10, we do have to split this first. So you have root 8 over root 15. We're going to multiply top and bottom by that root 15. On top, you have the square root of 120 now. On bottom, you have just the plain 15. No more radical on the bottom. The top, I think, will simplify a little bit. We'll split it into root 4 times root 30 over 15, and the root 4 is a 2. So 2 root 30 over 15. Okay, number 11. Your radical on bottom is root 7, so let's multiply top and bottom by root 7. So on bottom now you have 4 times root 7 is 7. 4 times 7 is 28. On top you have 3, and root 12 and root 7 is root 84. So now let's try to simplify the root 84. And we're going to do so by splitting it into the square root of 4 times the square root of 21. And I know that 3 times the square root of 4, that'd be 3 times 2. That is now 6 root 21 over 28. And we have one more step. Now the whole number, 6 and 28, that can be reduced. So the root 21 stays, and 6 over 28 would be a 3 over 14. Top and bottom, we're multiplying by root 3a. So times root 3a and times root 3a. On bottom, it simply removes the radical symbol. On top, I now have the square root of 32 times 3 is 96. You can multiply the stuff under the radicals, a to the 6th. We're going to break down the top. Let's see. Square root of 96 can be split into root 16 times root 6, and I know the square root of a to the 6th, so I don't have to change that. So now on top, I have a 4, which is root 16. Square root of a to the 6th is a to the 3rd, and the 6 stays put. Then on bottom, I have 3a. Now we have one more step to simplifying. The 4 and 3 can't do anything with it, but 3 a's and a single a, that leaves you with 2 a's on top. So there's my final answer. Number 13. Now I have a binomial on top. So when you multiply the top by root 2, make sure you multiply everything by root 2. So you have root 8 times root 2, which is the square root of 16, minus square root of 2 times square root of 2, gets rid of the square root. On bottom, same thing. So on top, you have 4 minus 2 over 2, which is simply 1. So that divides out to be, it's just a single 1. Multiply here, top and bottom, by root 12. So on top, you have 3 root 24 plus the square root of 72 over any radical times itself is, we remove the radical. So 3 root 24, let's see, the square root of 24 we can split into root 4 times root 6. Square root of 72, we can split into root 36 times root 2. So now we have 3 times root 4, which is 6 root 6, plus the square root of 36 plus square root of 2 would be 6 root 2 over 12. So we can leave our answer like that, but I notice all 3 of these terms are divisible by 6. Let's divide them all by 6, and that gives us a root 6, a root 2, and a 2. That looks better. It's just reduced. You can also split those with distributive property, divide them each by 12, and you'd get root 6 over 2 plus root 2 over 2. Either one of those answers would be fine. Now we have a binomial on bottom. To get rid of a binomial that contains a radical, you simply multiply by the conjugate, which is the exact identical thing, just change the plus to a minus or minus to a plus. Let's multiply top and bottom by that conjugate to make it legal. On top, you have 16 minus 4 root 2 now. When you multiply something by its conjugate, you only have to multiply the first, 4 times 4 is 16, and then the last. And that's the shortcut. Positive times negative is a negative. A lot of times we forget that negative there. Root 2 times itself is simply 2. So on top you have 16 minus 4 root 2. On bottom you have 16 minus 2, which is 14. We can reduce this by dividing every term by a 2. And that gives you 8 minus 2 root 2 over 7, final answer. And that can be split if you would like to. 6 minus root 5, we're going to multiply by 6 plus root 5. So do the same thing to the top. So the top is now 12 plus 2 root 5. The bottom, since they're conjugates, multiply 6 times 6 is 36. Negative times a positive is going to be a negative. Root 5 times itself would be just a 5. So now you have 12 plus 2 root 5 over 36 minus 5 is 31. There is no common factor that I can reduce by, so I am finished. Number 17. Got another conjugate, have another binomial, so multiply by the conjugate. 1 plus 4 root 2 on top and bottom. When you distribute the top, it gives you root 3 times 1 is root 3 plus 4 root 6 when you multiply the root 3 times root 2. On bottom, multiply 1 times 1. And you have to multiply a negative 4 root 2 and a positive 4 root 2. 4 times 4 is 16, and the root 2 times root 2 is 2. So that'd be 16 times 2. So that's going to be root 3 plus 4 root 6 on top. 1 minus, this is 32. 1 minus 32 is a negative 31 on bottom, and that's it. That's your final answer. Now let me show you something here. This negative on bottom, anytime you have a negative fraction, that negative can be placed anywhere, but you've got to be careful. You could place the negative out front, no problem. I just like to go over this every chance I have. However, if you want to place that negative on top, you can't do it like that. If you're going to place it on top, since the top is a binomial, that means the whole top would be negative, so you would have to put parentheses. So you can place it out front, no problem, or you can place it on bottom, but since it's a binomial on top, make sure that you put it in parentheses before you place it on top. The conjugate here would be root 5 minus root 3, so multiply top and bottom by that. The top is also a binomial, so we are going to have to FOIL the top. Multiply everything by 5. 5 times both of these would be a 5 root 5 minus a 5 root 3. Multiply everything now by root 5 would be a negative root 5. Negative root 5 times root 5 would be a negative 5. It removes the radical. Negative root 5 times a negative root 3 would be a positive root 15. So there's your new top. On bottom, multiply root 5 times root 5, you get 5. Minus, because it's a positive times a negative, root 3 times root 3 is a 3. So now let's clean that up. Nothing combines on top, is that right? You have a root 5, a root 3, no root, and a root 15, and root 15 does not simplify. So you now have 5 root 5 minus 5 root 3 minus 5 plus root 15, which none of it combines, over 2. Number 19. Your conjugate would be 2 minus 2 root 7. So multiply top and bottom by that. Since the top is also a binomial, make sure you FOIL it. So on top, multiply both by 3. 3 times 2 is 6, and 3 times negative 2 root 7 is negative 6 root 7. Then multiply everything by root 7. Root 7 times 2 is a positive 2 root 7. A positive times a negative is a negative. Root 7 times 2 root 7 will be a 2, and a root 7 times root 7 removes the radical, which will be 7. Over. 2 times 2 is 4. They're conjugates. And minus 2 root 7 and 2 root 7 will be a 4 times root 7 will be 7. So on top you have, this is 14. So your like terms would be a 6 minus 14, which is a negative 8. Negative 6 root 7 plus 2 root 7 would be a negative 4 root 7. On bottom you have 4 minus 28, which is a negative 24. Now, if you can find a number that divides into all these, now notice they're all negative, so let's divide them by a negative and divide them by a 4. So negative 4 into this gives you 2, negative 4 into this cancels and leaves you with a positive root 7. And on bottom, negative 4 into negative 24 goes 6 times. So that's a cleaned up version. Number 30, multiply top and bottom by 3 plus 4 root 6 is your conjugate. 3 plus 4 root 6. Distribute the 8, gives you 24 plus 32 root 6. Distribute the negative root 6, gives you negative 3 root 6. And a negative, this is a 1 times 4 is 4, root 6 times root 6 removes the radical, and you have 6. On bottom, 3 times 3 is 9. They're conjugates. Negative 4 times 4 is 16 times root 6 is 6. So that's what the bottom is now equal to. This is 24, so the 24 and the minus 24 cancel. 32 root 6 minus 3 root 6 gives you 29 root 6 left on top. And on bottom you have 9 minus 16 times 6 is 96. So that's going to be a negative 87. And again, that negative, since it's a single term now, you can just place it out front if you would like to. You don't have to leave it on bottom. 29 over 87 actually reduces to a 1 and a 3. However, you don't have to put the 1 on top because you still have the root 6, so we can leave that as negative root 6 over 3.